Probably the most interesting family or the group when it comes to chemical reactions in our syllabus is P block elements, simply because it is the biggest. We have talked about one portion of P block, that is boron and carbon family in standard 11, and nitrogen, oxygen, halogens and noble gases. These are the four families which we are going to talk about in this segment. Let's begin. This is our discussion of NCERT questions. They are very important, and especially with respect to inorganic chemistry, you would find that these questions of NCERT are valuable in competitive exams as well. So pay very special attention and let's begin. Discuss the general characteristics of group 15 elements with reference to their electronic configuration, oxidation state, atomic size, ionization enthalpy and electronegativity. So 5 typical trends have been asked. What do? Let's begin. Electronic configuration. Typically in group 15, if you talk about electronic configuration is NS2NP3. Please note 3 plus 2 is 5. 3 plus 2 is 5. And when we talk about group 15, group number minus 10 is equal to number of electrons in S plus P shells. This is a phenomena for P block. Please note this is not true for every family. This is only for P block. So electronic configuration is NS2NP3, and if you make a box diagram, this is the way it looks like. Pay very special attention. It has a special characteristic, extra stability of half-filled p orbitals. What about oxidation states? Oxidation states are again very interesting because it has 5 valence electrons. One common oxidation state is plus 5. Okay, so you have nitrogen, phosphorus, arsenic, antimony and bismuth. Do all of them show plus 5 state? Yes, all of them do show plus 5 state, and not just this. All of them also exhibit plus 3 state. Nitrogen is very funny in the sense, nitrogen, because it is a part of organic compounds, it can exhibit all the states from minus 3 to plus 5, including even fractional states. Wow. So plus 5 and plus 3 are throughout the group. Yes. In addition, nitrogen can show very, very interesting multiple other oxidation states also, because when nitrogen is a part of organic compounds, there are nearly infinite number of organic compounds, and that is why any possible oxidation state is true. Please note upper limit is plus 5. Then you also have plus 3. And is there a lower limit? Yes. The lower limit is minus 3. Can all of them show minus 3? Yes, indeed. All of them do show a minus 3 oxidation state. This is the general characteristic of group 15 with respect to oxidation states. Also, please remember, the stability of highest oxidation state decreases down the group as per inert pair effect. That means that plus 5 of bismuth is most unstable, or this is least stable. And interestingly, not nitrogen, but phosphorus in plus 5 is most stable. Somehow nitrogen also has strange ideas about nitrogen being very electronegative. So nitrogen also doesn't like plus 5 state much. Nitrogen is most stable in oxidation state 0. What? Yes. Look at nitrogen around you. Which is the oxidation state? It is in air, it is in your breath. Yes, and the oxidation state of that nitrogen N2 is 0. Nitrogen is most stable in 0. That is a strange exception. Phosphorus is most stable in plus 5. And the stability of plus 5 state decreases, and bismuth is least stable in plus 5 because of inert pair effect. This, my dears, is the trend of oxidation state in group 15. What about atomic size? Very simple. On moving down the group, you keep on adding extra shells, and as you keep on adding extra shells, atomic size increases down the group. So atomic size very consistently increases down the group. It has any exception? No, it has no exception. But again, don't forget, nitrogen to phosphorus is a rapid rise. Then arsenic, antimony and bismuth. The rise is, the increase in sizes, rather there is always an increasing order because more shells are being added. But the rate of increase goes down. Why? Because between phosphorus and arsenic you have D block, and between antimony and bismuth you also have D as well as F blocks. So if extra protons are being added to the nucleus, you find increases there, but not as much, simply because the rate of increase goes down with increasing number of periods. If you're confused, I'll just tell you some more data. See, it's like whenever we are moving from N to P, one extra shell is added. But between these, if you see, the difference in atomic number is 8. This difference is 18. This is 18. And this is 32. So one extra shell and you have just 8 extra protons. So size increases. You have one extra shell, but you have 32 extra protons in the nucleus. So nuclear pull increases and the size does not increase as much if you move down the group. This, my dears, is a very detailed analysis of trend of atomic size on moving down the group. Although sometimes people would say, just this much is sufficient. If you're happy, this is one line is very good. This is a very deep concept which I have told you. So if you take that, that is icing on the cake, but at least take the cake. Don't miss this. When we talk about electronegativity, as we move down the group, size increases, yes, very much. And electronegativity also decreases. So most electronegative is N. Then phosphorus is substantially less. And then we have arsenic, antimony and bismuth. Antimony and bismuth have nearly same value of around 1.9. And nitrogen is highest with around 3. Phosphorus goes around 2.2 or something. And these are roughly the values of electronegativity down the group in group 15. What about ionization enthalpy? As size increases, you find ionization enthalpy also decreases. So if you're talking about first IE, then nitrogen is highest, then phosphorus, then arsenic, then antimony, and then bismuth. There is a consistent decrease down the group. Reason? As size increases, ionization energy decreases.